Alright guys, so for this problem we're going to assume x and y are functions of t and we're going to evaluate dy dt. So we have x squared times the natural log of y is equal to -4 plus x times e to the power of y. So we have a little bit more information right here, but for now we're going to ignore that because that's what we're going to use once we find this dy dt, but first we're just going to focus on this top equation right here. So we're looking at implicit differentiation because we have dy over dt. So what this is saying is that we are taking a derivative of x and y with respect to t. So normally for implicit differentiation, you are looking at you're usually looking at a derivative of y with respect to x. So usually you have dy over dx. And so this is saying that you have d over dx as your normal derivative. D over dx is a derivative of x. But you have this y in here saying that you're taking a derivative of y with respect to that x. So every time that you have a derivative of y, you have to tack on that dy dx, and every time you have a derivative of x, you just keep it as a normal derivative. So for these problems, what we're saying is that we have d over dt, so we're taking derivatives with respect to t. So anywhere that we're taking a derivative of x, we're going to have dx over dt. And anywhere in this problem that we're taking a derivative of y, we're going to have dy over dt. And so looking at this equation, all we're going to do is we're going to differentiate, and we're going to use the similar steps that we use for any implicit differentiation problem. So here is our problem here. So the first step that we're going to do is we're going to multiply everything in the problem by d over dt, showing that we are taking a derivative with respect to t. And then anywhere that we have an x variable or a y variable, we are going to have to tack on that dx over dt or that dy over dt. And so this is anywhere that we have an x or a y variable, but we're taking the derivative of that. So I'm going to say anywhere that we have an x or a y derivative. Because remember, when you have the product rule, if you have an x, you're not necessarily taking that dx dt for that exact step, because in the product rule you don't take the derivative of x for every single step. And then the final step is going to be isolating dy over dt by itself and then plugging in the given information. And so the given information is this dx over dt is equal to 9, x is equal to 2, and y is equal to 1. So these are going to be the steps that we're going to take for this problem. It's really similar to any implicit differentiation problem, just instead of taking the derivative with respect to x, we're taking the derivative with respect to t. So now I'm going to go through my first step, which is going to be multiplying everything in the equation by d over dt. And so I'm going to multiply everything by d over dt. I'm going to get rid of the semicolon here because that's not a part of the equation. And so we have d over dt times x squared times the natural log of y is equal to -4 times d over dt plus x times e to the y times d over dt. And so now we can kind of separate this into little parts and plug everything back in. So for this side, we're going to have a product rule that we're going to have to work with. So I'm going to write product rule here. The derivative of a constant just goes to 0, so that is going to become 0. And then over here, we are also going to have to use the product rule. So let's take the derivative of this left side here. When we have the product rule, if we take d over dx, or just the derivative in general, you have f times g is equal to the derivative of f times g plus f times the derivative of g. So if our f function is equal to x squared and our g function is equal to the natural log of y, then our derivative of f is equal to 2x, and then our derivative of g is 1 over y. But remember that when we're taking the derivative with respect to our d over dt, we're going to have a dx over dt here, and then we're going to have a dy over dt here. So this left side of the equation becomes, so the derivative of your f, which is 2x times dx over dt, times your natural log of y, plus your derivative of g, which is 1 over y times dy over dt, times your f, which is x squared. So that is the left side of your equation. And I'm going to put a little line over here to show that now we're going to work with the right side of our equation. We're going to say this is equal to our right side, which is, again, using the product rule, our f is equal to x, our g is equal to e to the y power, our f derivative is equal to 1, and then our g, again, is also e to the y. That looks like an x. So now when we take the derivative of this f, we have dx over dt. When we take the derivative of this y, we have dy over dt. And so now we have, plugging into our product rule, we're going to have the derivative of our f, which is dx over dt, times our g, which is e to the y, plus the derivative of our g, which is e to the y dy over dt, times our f, which is x. And so now this is pretty much the whole equation that we have. I know these problems seem kind of complicated, and they're definitely like a lot of steps that you're working with, but once you understand the concepts of really what you're doing when you're taking the derivative of this x and y with respect to this t, it's really not that hard. I actually think these problems are really fun to do. I like implicit differentiation problems, but I know that that's kind of to each their own kind of thing. And so now for our final step, we need to isolate that dy dt. So we have a dy dt here. We have a dy dt here. So let's get everything else on the other side of the equation. So we can subtract 2x over dx dt times the natural log of y from this side. And then we'll subtract it, dx over dt times the natural log of y. So that's going to cancel out here. So then we're going to have 1 over y dy over dt times x squared is equal to dx over dt times e to the y minus 2x dx over dt times the natural log of y. And then we're going to subtract on this side the minus this ey dy over dt times x minus ey e to the y dy over dt times x. So now we're going to have 1 over y dy over dt times x squared minus e to the y dy over dt times x is equal to dx over dt e to the y minus 2x dx over dt times the natural log of y. For these problems, you definitely want to make sure that you are paying attention to every single step that you're doing, because as you can see, there's a lot of little steps that go into these, so just pay attention to what you're doing, making sure that you're carrying everything correctly. I'm just going to double check what I have over here to make sure my work looks correct. So we have this 2x dx over dt natural log of y plus 1 over y dy dt x squared. All right, perfect. Yep, all right, perfect. And so now on this side, we can pull out a dy dt. So we would have x squared over y minus ey times x is equal to dx over dt, which we could also pull out on the side, times e to the y minus 2x times the natural log of y. And now finally, our dy over dt is equal to dx over dt times e to the y minus 2y times the, 2x. 2x times the natural log of y divided by x squared over y minus e to the y times x. So again, a lot of this really is just algebra. It's nothing super crazy. The hardest parts of this are just really understanding what we're doing when we're looking at that differentiation in respect to t, and then making sure that anywhere you differentiate x or anywhere you differentiate y, you have dx over dx over dt and dy over dt with respect to that x and that y. And so now pasting this onto this page, and then I'm going to take the given information, which was what I have right here that we ignored in the beginning, that dx dt is equal to 9, x is equal to 2, and y is equal to 1. So placing that over here, I'm going to match up that y. So now we have dy over dt is equal to dx dt, which is 9, times e to the first power minus 2 times 2 times the natural log of 1 divided by 2 squared over 1 minus e to the first power times x, which is 2. And so now we can simplify this. Where did my thing go? Okay. So now simplifying this, we have dy over dt is equal to 9 times e minus 4 times the natural log of 1, which is 0, divided by 2 squared minus 2e. So now this is equal to, this becomes 0, so we have 9e over 4 minus 2e. And now looking over at what the answer key says, or what the possible answers are, it looks like we are going to have answer choice B for our dy over dt. It should be equal to answer choice B, because you can rewrite this as dy over dt is equal to 9e over, you could take out a 2, times, so it's 2 times 2 minus e.